At Walkoff Labs, we have a game-theoretic solver that takes player models and usage constraints for Major League Baseball players and outputs optimal management strategies that can be uh, used pregame, during games. We'll probably get into that later, that there's some challenges there, but then also in post-game analysis.
Okay. And why did you go after baseball?
I personally love baseball. I've grown up following baseball, uh, doing my own hobby analytics on baseball, and then I started um, researching it more seriously in the last few years as an undergrad and now a graduate researcher at BYU studying game theory and sports analytics.
Okay, great. And so you were a student working in the lab here, and your project was to optimize baseball. So talk about the pre-game analysis you were saying, like before a game, what might a team do using your tech?
Yeah, so in pregame meetings, a lot of times what MLB teams will do is they want to go through hypothetical scenarios. They'll ask questions like, when should we intentionally walk this batter on the opposing team? Or which pockets of the batting order do we want our pitchers going in for? And our solver, what it can do is before a game, it goes through hundreds of billions of hypothetical scenarios. And for every one of them, it's computing like game theoretic optimal strategies and like a list of like your priorities on which pitcher should be in the game or the win probability added if you intentionally walk or don't intentionally walk someone. So in the pregame use case, teams can walk through different scenarios or look at distributions on how the optimal manager would behave.
Mhm. And so if you're a baseball manager right now, how would you do that? I mean, Moneyball was maybe 20 years ago, so they're using some tools, right? They're doing some analytics, but do they still operate on hunches on this, or how do they make those decisions?
I think there's a wide range across different MLB teams, both from observing the game as a fan, but also from communication with teams through the company. Um, there's a wide range. So some teams with an experienced manager, it's very much the managers in the front seat, using their intuition to make decisions, with analytics on the side that they can, during a game, they'll ask for a card, or a little printed out sheet. They can't have technology in the dugouts, so for the most part. So a lot of times there's like printed out stuff where they'll look at it and be like, you know, this season, based on how everyone's been performing, this pitcher's a good matchup against these three batters and not against these guys. Other teams will do a more analytics first approach where they kind of will have almost like a playbook for their manager, as I understand it. But at the end of the day, I think pretty much every team, the manager's the one making the final decisions. The analytics are just a tool that can sometimes point the manager in the right direction.
Okay, and we know some human error is slipping in there because you can analyze games with your software and see that the software would have created better results, right?
Yeah, yeah, that's yes.
And how does that look like? How big a difference would it be for a team to use your software versus not?
Yeah, so it can be challenging to put an exact number on that because what our software will do is it will say, if this player model is correct, here is exactly how far you deviated, how many wins you lost. And according to our player models, when we've back tested this on previous seasons, it's somewhere between 5 and 10 wins per year per
Okay.
team. So that's a massive amount of wins. Um, However, that is under the assumption that our projection model is perfect, and we know it's not perfect. Like, you can never perfectly predict whether or not someone's going to hit a home run. So the number, I would think it's still on the magnitude of like multiple wins, but somewhere in that range.
Okay. Well, and if you tell a team, a Major League Baseball team, you can get, say, two more wins per season, that's huge. What's the response been like? Are teams aware yet?
Yeah, yeah. So the teams we've communicated with, I mean, there's some bias because we're only communicating with teams who are interested in our technology. but they believe this is something that's very important, and they believe it's something that can add that order of magnitude in wins. However, their main concern actually, as far as like how do we get this many wins out of it, it's
Hmm.
less about was your platform right on the decisions that we made yesterday. They seem to be able to trust that, especially because we let them use their own player projection models, so they don't even have to rely on our models at all. The the question and the bigger challenge is, are we gonna actually realistically be able to implement these decisions today or tomorrow? Because they're having to take into account buy-in from the manager and coaches, and then also a game is very fast-paced. And with you can't have technology in the dugout, and we'll probably get to some of this later, but, putting in the right pitcher at the right time, even if you can look up all the answers, it's easier said than done, 'cause it things are moving fast during a game.
Okay. So there's an adoption curve for a new technology. That makes sense. And so I should back up. I remember when you were first working on the technology, and then we were talking about it. And at some point, you realized, hey, this is pretty commercial, and decided to launch a company to do it. Can you explain how you got to that point?
Yeah. Yeah, originally, it was just a research project, I was working on with a couple other researchers and professors, and, the big part of our technology, the reason it's valuable is because and the reason no one has done this before is because baseball is a big game. It might seem like there are just, there's only 9 innings, there's only this many players, this many bases, but the game of baseball has, like, as many states as the game of chess. No one's ever gonna solve chess or know how to play chess optimally, and baseball is the same way. But what we were able to do, and we didn't know if we would be able to do this at first, is using some mathematical techniques and other algorithms, we were able to condense the game of baseball down to hundreds of billions of states, which is still an enormous number. But once we got it down to that number using some tricks and our algorithm, now that was something that was tractable and we could actually solve these optimal strategies, um, sometimes in as little as like 15, 20 minutes, which is what you need to when we were first going into this, we were like, people have done this with poker. But when they solved poker, I think they were doing like, it was on like all these supercomputers and it was taking like forever to run. And we were thinking maybe initially it would be something like that, where it would just be cool to know what the optimal strategies in baseball are, even if we can't create them quick enough for them to be used. And we were thinking maybe if we had this on a supercomputer for a week, we could get something interesting. But then once we realized, oh, we can actually, because of the way we've condensed this and set up our algorithm, we can actually get this in like 15 minutes. That's something teams could run before a game. And that's where we were like, oh, teams might find this really valuable. We should look into trying to monetize this.
Yeah, absolutely. And one application that occurs to me just on based on what you said there is, what if 15 minutes prior to a game, a player gets hurt or something? You might have, as a manager, you might have to completely rethink your strategy, and it could maybe step in and help you do it, right?
Yeah, yeah, absolutely. Especially like do you want to look into the platform at some point during this? We can,
Yeah, I'd like to know how it works, and you'll get
yeah.
over my head technically really quickly, but people are going to wonder, like, are AI tools being used? Like, what's the actual architecture of the thing?
Yeah, yeah, we could show some of the interface later and you'll see like we try to make it pretty user friendly where you can make some quick changes and kick off reruns, or you can solve multiple versions of the game if you're worried about someone not being ready at game time, or if you're not sure who the opposing team's lineup is going to be, you can do multiple versions and have those solving in parallel.
Okay, awesome. Yeah, if you don't mind pulling it up, I'd love to
Yeah,
show what it looks like.
yeah, absolutely. I'll just screen share here.
Cool. All right. And these are not necessarily customers. These are just games you have.
No, no, we would not show that.
Yes. Just making
Yeah.
sure.
Yeah, these are just some toy examples that I put in. These are real games. So the Dodgers Astros game I think is actually going on right now. I just put that in right before the game started with the lineups and stuff. And then these other games are some historical games that I thought had some interesting decisions that I wanted to look at. So we can look at do you want me to just go through like what a user would do if they're using our platform? So if I were the Dodgers, I would go in and I would create new game. And it would have my team automatically selected. As an admin, I don't have a particular team. And then we pull up the schedule here. They're playing the Astros today, so I think that's automatically selected. That will create this game. So now we've got our game here, and the first thing you do when you're creating a game is you need to put in your player projection model, which we call a matchup model. And this is like the foundation of everything we do. Like when we say you should make this decision, we're saying your matchup model wants you to make this decision. If your matchup model is true, this is the optimal way to act on it. That's the thing we're selling here.
And to create the model, how far back do you reach? Is this multiple seasons of data, or is it just recent games? What does it do?
Yeah, I'm going back in our matchup model. We're looking back multiple seasons. And I imagine MLB teams in their models are doing the same, where you can get pretty complicated in your matchup model. Yeah, but we kind of have a blend of, we look at historical profiles and try to line up pitcher profiles with batter profiles and see how they do against each other historically. But then we weight it more heavily towards the recent outcomes that we've seen.
Okay.
So you set the rosters, these get automatically loaded in. And now you continue to matchups here. And here we'll automatically generate matchups, but you could upload your own matchup model if you want here. You can also upload some more advanced settings like defensive skills and pitcher fatigue, which we won't do for this example.
And does every team basically have an analytics person or analytics team that would be the target person to use a tool like this?
Yeah, absolutely. Yeah, without going into too much detail, like some of the teams we've worked with, like they have several people where this fits in with the type of stuff they're already doing. Whereas they've tested our platform, they've had multiple people using it, and it goes in line with the type of questions that their teams are already asking before games. So now we've got our game created here with the matchups. I'll just go to this explore matchup section real quick to kind of show you what our matchup model is doing. We've got all the Dodgers pitchers here over on the left. We'll go with, everyone knows Shohei Ohtani. And this is how he does, according to our model, against every Astros batter on the roster. So all of these negative values mean it's bad for the batter. Shohei's a very good pitcher. So that's win probability added per plate appearance against all of their batters. And you can see how much of that comes from strikeouts or ground outs or giving up singles or home runs, everything like that. So teams can come in here, see what their own matchup model has to say about the game, or look at ours in this case. And then once you have a game, you can create strategic solutions. And that's where you actually set up rules for like what kind of decisions you're willing to make in the game. And then we'll optimize your strategy according to those rules. And for this section, I'm actually going to look at some solutions that I already made, so we don't have to go through the whole process of putting together a solution. And
what kind of rules might someone have?
Yeah. So that will be clear once I open this up. So I'm going to clone this solution here so that we can edit it. And teams can load in all of their defaults and everything. And I'm going to turn off, I've got some advanced settings on here. I'm actually going to turn those off. So first off, how an MLB roster generally works is you've got 26 guys that are allowed to be on the roster. You can only use those 26 on a given day. You can switch your roster from day to day, but you can only use 26 guys. And usually what teams will do is they'll say 13 of these guys are going to be batters, and they're going to play, they're position players that hit and play on defense, regular positions, and the other 13 will usually be pitchers. And in those 13 that are pitchers, they'll usually say 5 of these guys are going to be starting pitchers. So they're going to pitch the bulk of our innings. They'll start out a game and kind of go for as long as they can. And because they're doing a heavier workload, they only pitch once every 5 or 6 days. And once those guys are out of the game, maybe in the 6th or 7th inning, we'll bring in what's called the bullpen. And usually your other 8 pitchers live in the bullpen. And those guys are going to come in for just 1 or 2 innings and kind of finish off the game. So what a team will set here is they'll say, all right, this is the Astros. They'll say our starter today is Lance McCullers Jr. And we're going to say he's allowed to face at most 27 batters before he's, he can't go longer than that. It'll hurt his arm or he won't be as effective. And then all these other guys that I've checked here are relief pitchers, where you're saying once he leaves the game, these are the guys that we're okay with using. And like you can look at their recent usage, how many batters they've faced. So like another relief pitcher on the Astros is Brian King, but he faced 9 batters yesterday. So I said he's probably not available today. So the game theoretic solver knows that it can't call on him to come out of the bullpen. Does that make sense on the kind of
the totally makes sense.
So these are the rules. The rules you're setting here are which pitchers can be used, how long they can be used for. You can do some advanced settings going into how they can be used. We won't go into that. And you can even say like how many substitutions you're willing to make in this game, because you might say like we need to have a certain number of guys remaining for when we play tomorrow. And then you do the same thing with the position players, where this is now the Dodgers position players. And you mark for each player, you mark your batting order. This is the Dodgers' actual batting order for today. And you can put guys on the bench. I did a smaller version, so it would only take like a minute to solve. But if you wanted to put all of these guys on, that's where you're taking like maybe 20 minutes or so. And then you mark which defensive positions they're allowed to play during the game. And then the solver will work within those bounds when it's figuring out who it wants to substitute in.
And since this is published data, how far in advance do teams release their batting order?
Yeah, that's a good question. It can be anywhere from like 4 hours to maybe an hour or 30 minutes before game time.
Okay. So you might want to run a new analysis right before the game.
Yeah. Or we've had teams that are testing this out. They'll run one the night before. They'll usually know their own batting order before they know the opponent's batting order. But then sometimes they'll guess the opponent's batting order wrong and they'll copy a solution real quick like I just did, and they'll move a couple guys around and then rerun the solution. Yeah.
Okay.
And then this is kind of the bulk of it. So you've got the pitchers and the batters who are playing against each other. And what the solver is doing is it's looking at like every possible substitution and counter move that could happen throughout the entire game on both sides, where you've got kind of 2 little miniature battles going on, one between the Astros pitchers and the Dodgers batters, and then one in the other half of the inning where you've got Dodgers pitchers and Astros batters. And then once you set that, you can optionally set future games. I'll get into that in a second. You specify like you have to kind of bound the game to be finite. You say how many innings you're willing to solve for a maximum deficit. And then this tells you how big the game's going to be. So based on the constraints that, like we said, we can solve hundreds of billions of states, and the number of states determines how long a team has to wait before their optimal strategy is ready. This game is going to take 15 gigabytes of just raw information of strategy, and that'll be done in maybe a few minutes.
Okay.
And then the other thing, and this is actually, we'll probably want to get, this is the piece that teams have been most interested in using, is the series configuration, where if you're just trying to win today, do everything you can to win today, it's a challenging optimization problem for a computer, like we said, where it's doing hundreds of billions of states, and we have figured out how to do that. But it's actually pretty doable for a human as well. Because especially when they have analytics to work with, where they're like, we're just doing whatever we can to win today. We know this guy's our best pitcher. We're gonna use him. We know this batter does well against him. We're gonna use him. But in reality, in baseball, you're actually not just trying to do everything you can to win the game today. You're trying to do everything you can to win tomorrow and the next day and eventually win the World Series.
Yeah.
And all of these games are coupled together because if you use your best pitcher today, you might not be able to use him tomorrow.
Mm-hmm.
So you have to weigh the cost and the benefit of, maybe if we're winning by 1 or 2 runs, that's maybe a really valuable time to use your best pitcher where he's protecting a small lead and his value is really being utilized. But if you're losing in a blowout, using him would be a total waste because you're going to lose the game anyway. And now you might lose tomorrow as well because you've just used up your best pitcher.
Yeah.
And from what we understand from talking with teams, they don't really have a great way to analyze or solve this problem. This is where they rely really heavily on the intuition of their managers to kind of feel out like if they should pull the trigger.
Mm-hmm.
And what we do is we say, no problem, just put in your usage constraints for your pitchers. That's what you can do here, where you specify in your bullpen some parameters on like whether or not a guy can pitch 2 games in a row or how many batters they would need to face in order to be able to pitch 2 games in a row. And then we say, we're actually not solving just your game today. We're solving the next. In this case, I solved 3 games. And instead of maximizing your win probability, you're maximizing total expected wins. And when you do this, the solver will spit out strategies that tell you like when you should save your best pitcher for tomorrow versus when you should pull the trigger and use him today.
Wow. And so the multi-game aspect is one of the things that makes baseball such an interesting target for analytics like this, right?
Yeah.
I'm trying to think, are there other sports like that where you're making those multi-game decisions in the same way?
Not to my knowledge. Certainly not in the way baseball is. Yeah, you got football where you're only playing once a week. So everyone's going to be on the field and then they get a full week of rest. Basketball can be a little bit like this where you'll see teams in the NBA resting their players occasionally. But for the most part, NBA players can play every day. MLB pitchers, starting pitchers can only pitch in 15 to 20% of games. And relief pitchers can pitch more than that, maybe up to like 40% of the games. So like they're really heavily limited on how frequently they can be used.
I'm just wondering if after baseball, maybe cricket's next or something. I don't know. I don't know whether.
We've thought about looking into that. We haven't yet, but
Okay,
could
cool.
be interesting. Yeah, certainly. Where do you want to go next?
Let's see. Can we see the summary? Is that okay?
Yeah.
The final results.
Oh,
Okay. This.
once you solve a game, you're saying?
Yeah, that's what I mean.
Yeah, I'll just go to, I solved this game already, so I'll just go. Oh, I guess it's in here still.
Okay, just to see what the manager or analytics person actually
Yeah.
sees. Fine.
Yeah, absolutely.
Okay.
So here, first I'll show you how you can walk through a game. So this is like hypothetically, if you were able to have technology in the dugout, you could use this to like follow along with the game, and in each step it will show you the Nash equilibrium strategy. So here, wow, I honestly did not look at this beforehand, but it is really heavily favoring the Dodgers. It's saying if they were to play the Astros 3 games in a row and both teams played optimally, they would expect the Dodgers to win 1.94 out of the 3 games, which is quite a bit.
Yeah, that's why. And you and I have talked a little bit. Like this is targeting MLB teams is the most interesting and exciting thing to do with the technology. But definitely, like sports commentators could be interested in it. You could see ESPN or someone using this, or like prediction markets would be interested.
Yes, certainly. That's something that we thought about. We're definitely more interested in like we want this to be used to make decisions in a game to like enhance the sport. And we think that a lot of the decisions this recommends are really interesting and sometimes counterintuitive. And we think that could add value, but there certainly is potential for adding value for fans and analysts and other.
Or we talk about like fantasy baseball too,
Yes,
these other things.
absolutely. Yeah.
Yeah.
Yeah. So then what you do is you're in here and it knows all your options of what types of substitutions you could do. You can't make any pitcher substitutions yet because there's a 3 batter minimum rule in MLB, but it's saying the starting lineups are good. If you had to do a substitution for the Dodgers, it's like you could put in Will Smith for Dalton Rushing, but it would prefer to hold off for now. Dalton Rushing is not up to bat yet, and he's a young player, so you kind of want to let him play. But then you can just start walking through the game where you can say, all right, we got Shohei Ohtani up against Lance McCullers Jr. According to the matchup model, here's the probability of all of the next states. So Shohei hits a lot of home runs. It thinks there's a 6% chance of him hitting a home run here, 26% chance of a walk or a single, get a double, triple, or an out. And you can manually select whatever happens. That's what you would do if you're actually following along in a game. Or if you're just kind of playing around with it, maybe in a pregame situation, you can randomly sample from this distribution. It looks like he either drew a walk or hit a single. And you got Freddie Freeman up to bat. We can sample that. He got out, it looks like. Teoscar Hernandez looks like he also got out. And now you've got the ability to make a pitching substitution. And it tells you how much each of those decisions would deviate from the equilibrium strategy. It says don't do any of them. Keep McCullers in the game. He's your starting pitcher. We're only in the first inning. So
That's super interesting.
Yeah, go ahead.
Oh, is it fair to say, like, some people are going to wonder, is this AI making decisions? Could it make mistakes? But really, this is more of a brute force approach, right? You're just calculating as many options as possible, weighting them correctly, and then deciding what's likely. Yep.
Yes. Yeah. It's exactly that. It's a brute force approach. So, the downside of brute force approaches is that they sometimes take a long time. And that's where we've tried to get around that with different mathematical tricks and computing tricks to solve these in like 15 or 20 minutes. But these strategies are perfect to the extent that the player models are perfect. Mm-hmm. And the model itself, that may be a black box. Like but we don't really care because the teams can bring their own model.
Yeah, exactly.
And if they already trust their model, if they're already handing their manager a card that says what their model believes about their players, this is just a better way of translating that information, where we're saying, if your model is true, here is the way to follow it.
Okay. Fantastic. Well, thanks for the demo. I appreciate you putting it up on the screen.
Yeah.
Now, is there any kind of rule of thumb? Do MLB teams say a win is worth X dollars, or like, how do they value what it means to win?
Yeah, I think the loose rule of thumb is $1 million per run, $10 million per win.
Okay. So this is a technology that, like, conservatively you would say should be worth $25 million a year to a team. Is that
if they're able to follow its recommendations in every game, in every decision, then yes.
Yeah. Okay. Interesting. And for the game, I'm thinking, what if everyone adopted the tool? That's probably like no tool gets 100% adoption. But if they did, what it would do, I think, is push baseball towards actual skill and effort as opposed to, oh, the manager made a mistake. Is that fair?
Yes. Well, I think it would push it in that direction. I think it would do a couple things. One, it would probably push it towards player skill, where the whole purpose of this is utilizing players to the best of their abilities, putting them in the right spots, putting them in spots where they play well, rather than spots where they're going to get exploited or taken advantage of. But I don't view this as something that eliminates the need for a manager at all. Yeah. For a couple reasons. One, this is only the perfect manager to the extent that the matchup model is perfect. And no matter how advanced your analytics team is, no MLB team has a perfect matchup model. So you want the manager there. Well, one, the manager does other things other than just these
Right.
decisions. But two, you want the manager to know the weaknesses of their model. And I think the better analytic teams do this. They're transparent. Like if I were an analytics team in the MLB, I would not want my manager to just think analytics are analytics. I would want them to know what are our analytics actually doing and how are they wrong? When are they wrong? When should you trust them? When should you be skeptical of them? So that's one thing. I think managers will always play a role there. And then two, like the matchup model can't account for everything. Like there are certain things that are just you kind of need human intuition for. Like you know the matchup model is saying this guy hits 6% home runs here. This guy hits 4% home runs here. Go with the guy who hits 6%. But then you know that guy, he hurt his hip earlier in the game or something, or the pitcher's tipping his pitches and it's going to help your other batter instead of there are things like that where I think it will let the managers focus on more important parts of the game and the more human parts of the game and make the analytics easier to trust for what they are.
Yeah. Okay. Fantastic. And what has reception been like? The analytics teams have got to love it, but teams as a whole had what did they have concerns or what do they say?
Yeah, so it's been it's ranged from this is really cool, but our manager will never listen to this,
Okay.
so there's no point.
Yeah.
Um, that's been we had a team tell us that, and it was a prominent team with a good manager, so it was understandable, but at the same time, it's like no matter how good you are, you're not perfect, but understandable. So we've gotten that response, but then we've had other teams say this is something we could see ourselves using every single day. Um, but we have this wish list for how to make it fit with what we're already doing.
Okay.
So that's kind of been the spectrum of responses. So for that second category, we're working with a couple teams on getting them their wish list to kind of incorporate this into their flow and their pipelines for how they convey information to their manager.
Okay. And my sense is as long as the team will like financially treat your startup fairly, being very custom for a few teams might make a lot of business sense, right?
Yeah, yeah, we're not. That's not a concern. The market is 30 teams, and
Yeah.
we'll look at it's actually bigger than that. You've got international leagues and college teams, but the real market here is 30 MLB teams. So we're very interested in making things work. However, the teams we work with want them to work.
Mhm. Is there enough data that you could do it for college too? Do they report their stats as well?
Not as well as MLB does, but there's certainly enough data. You that's the nice thing about this is you don't really need most of the work is in the math. The data part is you need a model on, how many home runs does this guy hit? How many times does he strike out? And
Yeah.
you can have a pretty rough model, um, and you just have to put some uncertainty in there. And then it will say, according to your rough, uncertain model, taking into account all the uncertainty, here's how to navigate to the best of the knowledge you have.
Fantastic. Well, I know we're about out of time. The technology is so cool, Tristan. And thanks for talking to us about it. In terms of running a business, how's that going? Do you like it or how's entrepreneurship?
Um, I like writing code
Yeah.
and I like talking to MLB teams. I could do those 2 things all day. If I just had like a 50-50 split in the morning, I talk to MLB teams, they tell me what they want, and then in the afternoon, I go and write the code and get it done. The business maintenance, it is what it is, but we're making it work and we're having fun with it, so.
Yeah. Okay. Awesome. So many pieces. Well, good. Well, if people, hopefully, like I imagine some sports analytics people will see this, but if anyone's interested, how do they contact you?
Okay, yeah, so they could just reach out to me personally, um, through LinkedIn, just Tristan Mott, or through my email, tristan@walkofflabs.com. And our website, walkofflabs.com, also has contact information for me and for the team.
Okay. Fantastic. Well, thanks for doing this, Brad. It's a great technology, and good job with the company, Tristan. Appreciate it.
Thanks. Nice talking to you, Dave.